Here I have a simple loop of wire. My job is to make an electric current run around in this loop. The loop is connected to a galvanometer whose output is that point of light on the screen. So if I succeed in making the current run through the loop, that light will move back and forth on the screen. How am I going to make it work? Well, I've got to do it using magnetism. So here I have a bar magnet. To use this bar magnet to make a current run around in this loop is very easy. All I have to do is to move the loop into the magnet, or for that matter, back out again. That was it. That was the great discovery. Oh yes, and incidentally, one thing more. If I move the loop back and forth like that, then the current runs back and forth and keeps on going. Well, virtually all electric power, one way or another, is generated by that mechanism. In other words, that discovery is the very basis of our electrical civilization. And that's our subject for today.
Without energy, civilizations go nowhere, not even in circles. But with a strong and steady wind and a comparatively simple machine, an endless supply of power can flow just about anywhere, and once it's been converted to electricity, accomplish what the ancients probably never even imagined. These days, it looks easy enough on the surface, but to understand how wind makes electricity, it's necessary to dig a little deeper and to come up with a bit of historical perspective. The Dutch were masters when it came to windmills. Holland had more water and less cultivated land than she needed. So necessity became the mother of invention, and the Dutch became very good at using the windmill to turn the Rhine River Delta into good dry farmland. But by the 1800s, another kind of revolution was in the air, and it was the churning power and glory of steam. For all their majesty, the future belonged not to windmills, but to steam engines fired by the mineral solid called coal. Coal was inexpensive, as steady as a rock, and as convenient as the closest railroad track. So for a while there, coal was really cooking. However, in commerce and chemistry alike, few things have ever remained the same for long. And even as coal was gathering steam in the industrialized nations, a new and different element entered the picture. It was called electricity. Nowhere was it more hotly pursued than at the Royal Institution in London. And no one had pursued it more closely than the 18th century's most diligent and intuitive scientist, Michael Faraday. He probed the mysteries of science because, for him, the building blocks of nature had been created with a fundamental unity. And Mr. Faraday believed that the blueprint was to be found within the laws of physics. With that belief, Faraday was motivated to unearth a new link between two of Mother Nature's fundamental forces, magnetism and electricity. His quest began in 1821 with Hans Christian Ørsted's discovery that the flow of an electric current creates a magnetic field. First, Faraday reproduced the experiment, and then, in a roundabout way, he took a major step forward. He invented a device that kept twisting as it followed the circular magnetic field created by a current. And from this point onward, when people thought of things turning to create power, they no longer thought of windmills and steam engines alone. With this amazing device, an electric current could create physical work. In other words, this was the world's first electric motor.